So just a close.
Hi, good morning. Welcome to, we're going to be covering the submittals overview. What the intention of this training is to just kind of go over how submittals, what documents we will be looking at, and how submittals get created and building products and the manufacturers. Just trying to bring clarity to each one of those elements. So from our previous video on regards to construction overview process, we talked about there was the when the estimator lands a contract, we then begin to do the job setup. And part of the job setup is we manage some of the information, which is setting up the submittals and, let's say, the submittal log. And to do that, we need to look and check with the spec sections. So we're going to cover the element of spec sections and cover the element of regards to double checking with the drawings and what the drawings show. And then when the submittals are finally approved, when they go into a closed status, how they get issued out, new submittals that come in, and we're gonna lightly dabble on the topic of shop drawings. Okay. So based upon that, I'm gonna close this out. I've created a, I sent to all of you a Google spreadsheet that has a general overview of some of the spec sections we cover. So let's jump into specs. So on every single project, you're going to get specs. So let me jump into that now. So where we file them on the project. So in our project folders, you can pick a project. So let's name, what's a project that we need to do submittals on right now? Or just any.
If you want, you can go to the UCSF elevator. I've kind of started some of the submittals there, unless you want a clean slate.
No, we're just going to go to the spec sections. So UCSF elevators. I'm not able to click down on my sheet that way. Well, in this example, let's do current health. So in current health, inside of the job folder under project management, you'll see a folder called specs. Inside of the specs, this particular folder has a folder that says full specs and bidding specs. So let's take a look at full specs and what that looks like. I need to shift my drawing here. I apologize for going slow. I have a lot of controls that I am trying to work through here. Okay. So if you guys are seeing my screen, you should see the project manual. So at every project, the general contractor issues a project manual, and part of the project manual is the spec sections. So as we look through here, you'll see a table of contents. The project manual, the spec sections refers to that. So you see that there's a division 0, which is the procurement and contracting requirements. Then division 1 is the general requirements provided by the owner. Basically, the owner saying, here's how I want my building to be built, and here's the requirements that are required in order to build this. This could be building code, this could be city code, this could be any kind of specialty items, this could be paperwork and documentation for insurance compliance. Everything in Division 1 is usually just a big overview of all the things that are required. So on one of our projects, it's not Kern, but Los McDonald's project, they added in a new spec section for BIM, which is Building Information Modeling. That was a new spec section, included that into our scope. But as you'll see, there is what they refer to divisions. So division 3 is concrete, division 4 is masonry, division 5 is metals, division 6 is wood and plastics, composites, division 7 is thermal and moisture protection, division 8 is openings, which is usually windows and doors, division 9 is finishes, 10 is specialty, and it goes on and on and on for different divisions. And what they will do is they will have subcontractors like us bid on certain spec sections. Okay? Different projects have different numbering for their spec sections. Now let me clarify that. They usually everybody has a division 3, a division 4, division 5, 6, 7, 8, 9, 10, and so on. The divisions are usually standard and are determined by the architects, the International Architects Agreement, or a formality that all building inside of the United States fits within these divisions. The numbering underneath, as you see here on division 5, you'll see it says 051200. Different projects may have a different number for the structural steel framing. So our scope in this case, the scope that we bid to was 054000. On different projects, the metal scope, the cold formed metal framing, may be 054100 or 054010. So they may have different sub numberings, but they're usually always in the same division. Okay? So don't get confused if there's a certain numbering system that throws it off. Okay? So you could look at different projects to find those things out. Now let's jump into layers on top of layers. Oh my goodness. So let's jump back to my Google Sheets. So I don't know if you can see that. It might be a little tiny. But there's Division 5 metals. Division 5 metals, cold form metal framing. That traditionally is always structural steel. Okay, that's the I-beams, that's columns, everything related to the structure and the integrity of keeping that building upright. This is all load-bearing stuff, is in the Division 5 section. Sometimes on some of our projects, we build roofs, we build exterior walls. All that falls in with the 05400 cold form metal framing spec section. Okay, some projects, they want us to do Division 6. Now this is the woods, plastic, and composites. I'll just zoom in here to make this a little bit larger. Wood, plastics, and composites. The scope that we usually provide is plywood. If we're doing plywood, pressure treated plywood, things like that, that falls under the carpentry or rough carpentry scope. Anything related to wood is in Division 6. Division 7 is your thermal and moisture protection. These are the scopes that we traditionally do, will affect us. In regards to thermal insulation, rigid wall insulation, blanket insulation, fire stopping, joints and sealants. And there's this other item here called self-adhering sheet waterproofing. That only applies to us if we're doing plastering. So now that we have a new plaster division, the plaster division, when they're trying to put thermal or moisture protection, making sure the building's waterproof and that it's got a coat on it, that usually comes partnered with the plastering spec. Sometimes it's included, sometimes it's not. They just want us to provide the plastering and they have somebody else doing that scope. But you may see those parts and pieces. The Division 9 is the finishes. You're also going to see Jift shap wall assemblies, cement plaster, non-structural metal framing, suspension systems, gypboard, drywall ceilings, acoustical ceiling panels, and specialty ceilings such as like a wood ceiling that we have out at Sonol. These are traditionally our divisions that we are bidding to. Different projects, we're only bidding Division 9 and only aspects of Division 9. Sometimes we're only building Division 7s, sometimes only Division 6, and sometimes only Division 5. So the part of this training is to cover all the things so that we have a sense of what all that is in case we can look job by job, because every job might have a combination of some, one, or all of these items. So what I did to help the team out is I've created a list next to all the spec sections of all the different types of products that are normally associated with that spec section. Now again, this is an overview, so I did not cover all of them, but I covered the big line shares of them. So cold for metal framing, if we were to look at that, usually has studs, top track, bottom track, clips, CRC, flat strap, anchor bolts, hold down, screws, weldings, and pins. Those are all the different elements that are usually used to build the exterior wall system. So you're going to see components like metal studs. Metal studs go inside of you're going to have top track or slotted track. There's a bottom track component. There's usually sometimes a clips. And to make the wall more rigid, there's CRC that's usually sometimes put into the exterior system. Flat strap for any kind of strapping and bracing and blocking. Anchor bolts, hold downs. Anchor bolts are the things that go into the bottom track that tie the exterior wall into a concrete form. Hold downs are it's a bracket that attaches to the metal studs that it's used to screw onto the anchor bolts and part of the hold down system to create rigidity in the wall. Screws, which are used to fasten the metal components together. Now, I want to take a minute here to just talk about how things get attached. So there's some distinctions as we go through all these different components, that when you're attaching things, whether it be metal studs, plywood, insulation, there's different ways to have different components or building materials attached to each other. So in your spec sections, you might see something under attachments, or it will say fasteners. Okay, so when you're attaching two things together, when you're building something, one of the ways to attach something together is what they refer to as mechanically fastening it. So you'll see fasteners. To mechanically fasten something together, that's usually referred to as screwing things together. So we use screws to stick things together. We also attach our metal stud framing to steel, structural steel. And how we attach that, we use pins, which is, think of it as like a really thick nail. It shoots into that. Now, when you're attaching steel pins, they call them steel pins because the pins are meant to attach our metal framing to steel. They can't hit the nail with a hammer, so they have to use what they refer to as a power actuated device. And what they use is think of it as like a bullet. A bullet consists of a casing which has gunpowder in it, and the tip of the bullet is the projectile that goes out the front of it. Well, in this case, the pin is the tip of the bullet, and the shell casing that holds the gunpowder is what's used, or powder actuated device is what's used to act just like a bullet. So if you hear people talking about power actuated devices, you may hear our guys refer to it as a load. It is essentially the same thing as a bullet, and it acts the same way as a bullet. Like a 22 round, they will refer to it as a 22 load. You have 22 loads, you have 12 gauge loads. The bigger the number, the larger the capacity of gunpowder that's using to push the pin into the steel. And it sounds like a shotgun shot. So this is where safety, they'll put in ear protection, things like that. So pins and screws are used to fasten things. What's another way to get things to stick together?
Welding.
You could use welding. Welding is melting two pieces of metal together. When you deal with welding, there's a whole nother slew of paperwork and different set of products that you need to provide for welding. So there's lots of different types of welding. You have MIG welding, TIG welding, and we'll do more research on that a bit later, but there's welding procedures. You're using electrode welding or using gas welding. So this topic of welding, the products that you need for welding, it starts to expand. What's another way to get things to stick together?
Glue.
Glue, yes, that's right. So there's glue, or we refer to them as adhesives. So you'll hear us talk about drywall adhesives. So you'll see that down underneath here under gypsum board. Sometimes we'll provide adhesives to glue pieces together that will allow things to adhere to each other. So glue is another way to stick things together. So we got screws, we got welds, we got pins. Those are all mechanical fastening or melting together. Adhesives is gluing stuff together. Is there anything else that comes to way to stick stuff together?
Anchor
Mud.
bolts.
Mud. So mud will have an adhesive inside of it. Yeah, that qualifies. Could be part of an adhesive. Yeah. Now, what did you say? I heard something else.
Anchor bolts.
Anchor bolts. Anchor bolts is a bolt with a washer and a nut on it. So it's different than a screw, but that's another way to fasten and hold stuff down. Yeah. Or to attach things. Yeah. What about for insulation?
Pins.
Yeah, you're going to do pins and straps. Can you just stuff insulation into the wall and have it stay there?
Yeah.
Yeah, you can. So you could think of it as if you were at a door, can you wedge a piece of paper into the side of a door? Can you just take some paper and wedge it in there and stuff it in there and it'll stay?
Yeah.
Yeah. So that's referred to as friction fit. So you can take insulation and stuff it inside of a wall cavity, and you don't need to provide any other types of fasteners because it's referred to as a friction fit. And that would be under either fasteners or attachment points. There'll be a line in there saying, oh, we're just going to friction fit it. Meaning we're going to put more material inside of the space, and because of the capacity, we're going to wedge stuff in here and it will hold itself up. Okay? So those are all the different ways to get things to stick together. There's also another way using chemical compounds. That doesn't occur in our work, but it does fall underneath the joints and sealants. Sometimes they do chemical reactions. It occurs in plastering. Plastering, they use different chemicals like lime and fiber and stuff to get things to adhere to it inside of plaster. Okay, so chemicals is another way to get things to stick together using breaking down chemical compounds. Okay, so in covering the metal framing, all these are different components that we will be submitting on. Now, there's more extensive a list, but where you will find that is you will look in your spec section. Inside of a spec section, so in this spec section, cold form steel, let's take a look at that. So much stuff going on here. Let's take a look at the bidding spec. Cold form metal steel. Cold form metal steel consists of, every spec session consists of 3 major parts. Part 1, let me just hide this. Part 1 is the general part.
Vicky, is there any way you can make that a little bit bigger?
Yeah.
Please. Thank you.
Yeah. So part 1 consists of the general part. So the general part is literally just giving you a general overview of the spec section. They're going to tell you about related documents. They're going to tell you about what they cover inside of it. They're going to give you definitions. They're going to give you different subsets of, this is per 2016 California Building Code, how to actions. You need to provide product data, submit this, shop drawings. Usually it's everything required as part of the other sections. So part 1 is just a general overview of that particular section, and it'll call out ASTMs. It's going to call out how to deliver and store things. Okay, so part 1 is the general overview of that. Part 2 is the products. This is the list of the products that you can use on the project for this particular spec section. So we're in the cold form metal framing section. And here is a list of the products. And there will be bullet points and indents to do this. So 2.1 is the performance requirements, meaning any product that you do, it needs to comply with this wind loads, seismic loads, story drift, deflection limits, thermal movements, cold form metal steel framing standards. Wall studs need to comply with this AISI. Headers need to comply with this AISI, fire resistant rating. And then it'll jump down into, I turn the page here, 2.2 cold form metal steel framing materials. It actually jumps now into the materials that are approved to use. So they want recycled content to be per this. They want the steel sheet to comply per this ASTM. Now, what is an ASTM? An ASTM is an association of standard testing materials. So there's an organization out there that all they do is test. They create the standards for testing. Okay, so an ASTM, as they create a test to say this complies and meets this level of testing, there'll be an ASTM number. Okay, so that's all ASTM stands for. So as you see ASTMs, they're just pointing out, hey, there's a test that we have to meet. So this talks about the steel sheet. It has to meet certain coating. Here's deflection clips, have to meet this ASTM. Our non-load bearing metal framing. So as you see, we went from 2.2, which is the material. Now it's going into the non-load bearing wall framing. So this is where it points out the steel studs, the minimal base thickness for exterior walls, interior walls, referring to the thickness, the flange depth, the flange width, the properties. Here's the steel track, the vertical deflection clips, drift clips, Z-furring. So this gives you a list of all the building components that are inside of the non-load bearing wall framing. Those will be the items that we will need to submit. So traditionally, what project managers do is they read the specs, we go through and we highlight the items that are needed for us to submit on. So in this case, You have exterior walls. We have to maintain a 0.054 mil thickness and a 0.33 mil thickness. And they're 6 inches. So the exterior is not to exceed a 6-inch wall thickness, and flange width and how steel stud track. So this begins to give us a list of all the components that are needed that we need to build with. And so if we're going to do ceilings and soffit framing, here's what's required of that. Framing accessory pieces, anchors, clips, fasteners. Here's where it talks about if you're going to anchor, clip, or fasten something, here's where anchor bolts need to comply with this. If you're going into concrete, meaning post-installed concrete anchors, here's what it needs to comply with. Power actuated fasteners, mechanical fasteners, welding electrodes need to comply with the American Welding Standards Association or American Welding Society standards. Miscellaneous materials that if you're using, let's say, whenever we do welding, traditionally we have to paint the welds so that the welds, when you melt two pieces of metal together, the oxidation of those metals can rust, which will deteriorate the weld. So you have to use a zinc paint to go over the top of it to make sure that it doesn't corrode the weld. And that will be in here. So galvanizing repair paint, that happens in here. Different ways to provide shimming, what's acceptable, what gauge of thickness of a metal shim. And then if you're going to do fabrication. So iron workers, so inside of this scope applies not just to us, but the iron workers also have to follow these same standards. And they may have work that they need to provide inside of here. So they might provide sealer gaskets and shims that we don't provide. So you might have multiple scopes inside of a particular spec section. Okay? And fabrication. So when they're making this, so when they're beginning to fabricate the steel, it has to comply with all of these different items. Okay, so we've covered part 1, we've covered part 2. Part 3 is the execution. This is how you actually install the items out on site that they're saying needed. So you have to examine the work, you have to prepare the work, and then as you begin to install, it's saying that you have to cut the framing members, you have to fasten them together or weld them. You have to also provide bracing. You have to install insulation. And if there's insulation that's required, it will refer you to a different spec section. So when building the metal stud wall, there's other spec sections that other building materials that may need be part of the assembly. This is where it will refer you to other spec sections to build the full wall. Okay, and it goes on and on for spec section number 3 for non-load bearing wall installation, how to fashion both flanges, how to set things plumb. This will also give you construction tolerances. It'll refer to things as shop drawings. So let's talk a little bit about what is a shop drawing. So the architect provides drawings. Anything that is specific to a subcontractor or to the general contractor that they're going to be providing additional detailed information is referred to as a shop drawing. So a shop drawing is any drawing or any bit of information that is particular to someone's scope that's being added into and enhancing the set of drawings. And it usually comes from back in the day. They called them, oh, that came from the shop. Oh, the guy's particular stuff, the shop. Oh, the shop drawings are coming in. So that's how the terminology came about, was they just referred to it as the architects got the drawings, any other shops that are providing their own drawings is referred to as a shop drawings. Shop drawings have to go in a submittal and be approved by the architect to make sure that it complies with its building. And then everything gets adjusted. So shop drawings was the way that everybody collaborated on the project in the past. What's now happening with technology is that instead of shop drawings, what's now happening is they're using computer models. So now they're not using just paper sheets to compare what does your drawing say, what does my drawing say. They're all collaborating inside of a model. They're using computer technology to collaborate their models, and those models can produce shop drawings. So with technology, you're at the verge of seeing some things change in our industry in regards to this. Okay? So we've covered part 1, part 2, and part 3, which gives us a list of spec items. Any questions about what we covered in regards to the specs?
No.
Okay. So back on our presentation, we said, well, we got to check the specs to know what the building materials that we're building with, and we also have to check the drawings. So in this case, what you do is you go in here, inside of project management, you go under plans, and then here's the set of drawings. When you go in to check the set of drawings, usually the first page is referred to as the cover sheet. And on here, you'll see what they refer to as the project sheet index, or sometimes it's called the table of contents, or it's sometimes called the sheet matrix. Lots of different words for the same thing. It's just an overview of all the sheets. So the sheets that apply to us is the general sheets. We overlook these. Civil. Civil is the earth movers. Civil construction deals with utilities and how things affect the earth. That's civil construction. Landscaping is basically the irrigation of the topsoil, how water's going to drain and how the things are shaped. Structural. So if we're in the 05 division, which is metals, that's structural load-bearing stuff. The structural set of drawings will apply to us. Architectural refers to the look and feel of the building from the inside and outside, but not necessarily the structural component, because that's picked up in the structural drawings. Architectural drawings, this will apply to cement plaster, this will apply to joints and sealants, it'll apply to drywall, it'll apply to non-load bearing framing, it applies to plywood, insulation. Architectural set of drawings will apply to all the other different sections. So let's take a look, for example, of where do we look if we wanted to find out how the walls are formed. In the architectural set, they usually follow a certain numbering system. The A1s, in this case, the A111 refers to the floor plan, an overall floor plan, and as they begin to zoom in, they may break the floor plan into 2 sections, like an A and a B, because the building's so big that when you zoom in, that you need a more granular point of view. So the way you could think of it is looking at a map of the United States is A1111. Looking at the map of eastern half of the United States, and B is looking at the western half. So it allows you to zoom in on a certain level. And then A1112 refers to the reflected ceiling plans. Now, earlier we talked about not all spec sections are numbered the same. As architects will create their own numbering systems inside the structure of the divisions, architects always follow the same type of divisional drawing sets, but when it comes to their numbering, they will change their numbering. Meaning, if you're on one project and sheet A111 is the overall floor plan, if you go to a different project, they may call it A0.1 is the floor plan. So there's a different numbering for that. And another example of that would be the reflected ceiling plan. Sometimes the reflected ceiling plans are not in the A1s, they're in the A2s. So A1s are floor plans, A2 are reflected ceiling plans, or sometimes the reflected ceiling plans are in the A6s, meaning it'll say A-6 and then some numbers behind it. So in this case, getting familiar with your projects as project managers, we have to get familiar with the specs and we have to get familiar with the drawings. So we're looking for wall types. Because we're building walls and ceilings on most of these projects, where do I find the wall types? There's usually a sheet. Let me see if this, I'm zooming out to see if there's any. In the A section, there should be, here's the example, A521 interior wall assembly details. Let me see if that, yeah. So this architect has labeled their interior wall assembly details on A521. So let me step over here. Okay.
Looks like Bart.
So as you go into these walls, they'll be pointing out, here's what the bottom of the shaft wall looks like. And it will start naming the components. Wall per plan, mechanical shaft. Here's the bottom of the shaft with J-track, 1-inch liner panel with a CH stud, 2 layers of 5/8 type X drywall board with fire resistant sealant and suspended ceiling per plan. So when you look at the drawings, you'll be able to highlight, here's the building products that they're referring to. Oh, I did something and I don't want to do that. Okay.
For these set of plans, they're really touchy, so if you want to highlight, you have to zoom in really close and go really slow.
Okay. Thank you.
You're welcome.
So you'll need to look at your drawings and you'll need to look at your different wall types. So in this case, they're pointing out here on the exterior details, they're pointing out that A6 walls have a component like this. So you can see that they're using cement plaster here. They're pointing to, I'll zoom in here. You can see that they're using cement plaster. They're using a J mold. And this is so if I was to color this, and I know this is going to be tough, but let me go with it. So this material is cement plaster. This material here is the air barrier. This material here is the drywall. This material here is the insulation. So you're gonna have to, I'm using it just to make the point, which I think you guys get it, is that because it's black and white, it's a little tough to see. So sometimes I will color my drawings so that I can make sense of it. So that I can see that, oh, cement plaster is here in yellow. This is pointing to an air barrier, which is here in orange. There's a joint and sealant right here, pointing out that there's some caulking here that stops any water or anything going in here. Let's see if anything's put it. Steel stud side and spacing per deferred approval, maximum outline of plane deflection L/600. But there's a drywall here. That's a common key that you'll see. So as you begin to look into the drawings, you can look in and see what they're pointing to. So it gives you a visual representation of how they want things built. So in this case, they want a 3 5/8 stud at 24 on center. So we need to have a submittal for a 3 5/8 stud with top and bottom track. This squiggly line that's in here, that's insulation. This has an attachment clip. So we need to look about attachment clips. They want fire safing. So we need to see a fire safing. If there's joint fire stopping, that's maybe in our scope under joints and sealants. Traditionally, when they're building the wall, you're looking at the walls, they don't specify anything specific. They're just referring to the building members. Sometimes they will call out for something very specific. In this example, you'll see here, they want a gasket laminated to both sides of the mullion. Gasket shall be a 7 to 11 pounds per square foot density, neoprene with EPDM SBR blend with shore duration of 25 to 50 equal to the American National Rubber number, Rubitex International or equivalent. So they're being very specific about this particular item that it may not be reflected in the spec section. So the drawings sometimes have more of a detailed specificity about the product than the spec section does. So we're looking at the specs and we're looking at the drawings to see. Now, once we get Bluebeam fully upgraded, one of the options is what we'll be able to do is that if the drawing is referred to as OCR, which means all the text gets elevated up and is searchable, you can come up here and you can search and look for drywall. And it will find all the pages that has it on a certain number of sheets where drywall occurs. Or you can put joints and sealants. Things like that will come up where you be able to look in. As you can see down here, it's very tiny. It's looking through all the pages to find out where the word drywall occurs. So in this case, I clicked the sheet. It came up here to tell you, here's where drywall occurs. Here's their gauge chart for them to determine what the millet thickness and what the gauge is specified. Oh, wow. They even put in the nomenclature here. That's great. So on this sheet, this refers to as the wall types on A601. I'm changing the property of this because that's a big deal. So this ties back to how the estimator estimates. When the estimator estimates, he says, oh, I'm going to build the wall. The architect has a sheet referred to as wall types that tells you here's all the different types of walls on the project. And here's all the parts and pieces. So wall type A consists of, I don't know if you can see that, a 3 5/8 inch steel studs at 24 on center unless otherwise noted, and 5/8 drywall on both sides. Now this 5/8 drywall does not say that it needs to be fire rated. But in this example, you'll see down here, it says, well, if it's a type A, it's as shown, but if it's a type A1, it's the same as an A wall, except for it uses type X drywall, which is, type X is a fire rating, okay? And then there's an A1.4, which is same as that, except for it has tile on it, an A3 wall, and A-this. So the estimator goes through and looks at all the wall types on the floor plans to determine which walls we're going to be building with, and he provides a price saying, oh, we need to build this wall with a 6-inch stud, 5/8 drywall, and glass fiber insulation. So what Allison has been doing is she's been reading the specs and she's been going through the drawings to determine what are all the building products that are needed to build this wall. What are all the building products that are needed to build this wall? And you'll see here, they'll say steel bridging, And if you go to that detail in the drawing, it will refer to what the steel bridging is that we need to submit. If you guys have any questions about this, you'll just reach out to me and let me know, and I can help with any of this stuff. So if you were to walk through, and I don't want to take long on this, but just to walk through is that if you were looking through the set of drawings, you look at, let's say, the floor plan. As you're looking at the floor plan, you'll say, okay, here's restrooms. And I need to look at this is the overall. I need to look at the partial. As you look at these walls in this large conference room, here's the door. This is calling this wall right here to be a wall type A. So if you want to know what a wall type A was, you would come over here, jump back over to your wall types. You'd go, well, which one is wall type A? Which we know a wall type 1A consists of 3 and 5 steel studs, which is top, bottom track, and a steel stud with insulation and 2 layers of drywall, one on one side, one on the other side. So the estimator will create a price for that wall assembly and then come back to the floor plan. To say, oh, this is a wall type A, so I'm going to highlight this a certain color. They'll highlight this wall here a certain color. And here's another wall type A. And here's another wall type A. And they'll go through this full set of drawings, which you may see in your progress maps. When you look at the estimate will have all these walls highlighted, which ties into a calculation to build our estimate up. Okay? So we want to be specifying the building material that we're going to be using in wall types 1 or in A. And that's where we start to create our submittals from. Any questions about what we've covered so far?
No. I've got a quick question.
Yeah.
Could you elaborate, like, what is the best way to figure out which wall types are your wall types, so that way you don't necessarily waste your time looking at the entire plans and pulling all the product data for every single bit of material going into the project?
Yeah. So traditionally, my process is I look at the estimate and I will look at the drawings of which they highlighted, and I look on the floor plans and I look at all the wall types that are highlighted. So in this case, there's lots of A-type walls. So I'll write down a little note. I need to do A walls. Oh, here's a B-type wall right here. So I'll go, okay, I got A walls, I got B walls, I got an F, a D wall. And I'll look at the floor plans and just look to see which walls are they calling out. And from that, I will then jump to the wall types here. And I saw that I had an A wall, B wall, C walls, Ds, and an Fs, but I didn't see any double Es. So on this page, I know to submit information on the As, Bs, Cs, Ds, but what's a double A? And I'll look through here and say, oh, a double A wall consists of an exterior, there's 5/8 drywall, there's steel stud framing. So I may not be on a page that has that wall type, but I know that that affects our scope of work because we're doing the metal stud framing. So I'll either try to find out where that wall type occurs and how much of it, but I'll submit information on there. Wall type EE. Wall type EE consists of adhesive masonry veneer and mortar. That's not our scope of work, so wall type EE doesn't affect us. So I will use the set of drawings to lead to the types, but I'll also go through the types to make sure that in case the estimator missed a wall type, I know that that occurs somewhere in the project and that we might need to submit information on it. So in this case, if there's a type H, is this our scope of work? 7/8 hat channel with drywall?
I would say yes.
Yes, if we have the drywall scope, this affects us. Okay, so we may have not seen it on that page, but that's what I go through. As I go through the wall types, I go through the plans, I go through the floor plans, wall types, and then if we have a ceiling scope, I'll go through the reflected ceiling plans, which is here. This is the overall reflected ceiling plans. And again, they will specify, I'll look at the estimate, and they're calling this out to be, in this case, this is drywall here. But if the acoustical ceiling tile is called out for anything, then we'll, so right here it says gypboard. So if we're doing anything with ceilings, that's where I would get the information from. Did that answer your question, Allison?
Yeah, it did.
Okay, so I go through floor plans, reflected ceiling plans, wall types, and ceiling types. And that gives me an overview of some set scope of our work. So in this particular project, you'll see, this is the current project. I see that there's 3 main types of ceilings, actually 4 main types of ceilings. I see there's this speckled type, which is the drywall. I see this grid type, which is acoustical ceiling tile, which is the same that's above your head in your guys' office right now. That's acoustical ceiling tile, which is why they do 2x2 squares, because that's what it looks like in real life. And they have drywall around it. And then there's this other piece called linear wood ceiling system. So there's a wood ceiling here. Now, this may not be our scope of work. On the Sonol project, that is our scope of work. So that's why we have to look at what the estimator bid in their spec sections to determine if this affects us, because project by project, it changes. So I can see that there's those type of ceilings, and then there's something here that looks like there is no ceilings in these rooms. Now, the reason why there's no ceilings, these are equipment rooms and electrical rooms, so they don't want a ceiling in there. It's fine to have it opened up all the way to the deck. Okay? So that covers drawings, that covers specs, and what we're looking for to give us a sense. And now we're going to jump into the building material. Okay? So from here, the spec section, I put items in here. I thought there was something else I just saw. There was clips, there was something. It'll come back up. So plywood, knowing what our spec sections cover. So on this tutorial sheet, I put a tab down here for metal framing. Now, before I jump to that there, is metal framing in Division 5? Yes or no?
Yes.
Okay. Is metal framing also in Division 9 under non-structural metal framing?
Yes.
Yeah. So you see there's studs and top track and bottom track in Division 5, and there's studs, top track, bottom track in Division 9. So when we create our submittals, we're going to be using a lot of the same building material. Okay? So let's jump to the building material and how all this kind of comes together. So metal framing. So metal framing, when we're talking about metal, steel stud metal framing has different components. Let me zoom in here. Can you see that? Okay, Vanessa?
Yeah, yes, I'm gonna change it here.
Okay. And feel free if you want to sit on your.
No. I just made a big. I switched it in our computer over here.
Okay, good.
Too.
Yeah. So here you see that studs. Here's the components of a steel stud. You need to know the size of it. These are the traditional sizes we use: 2.5, 3 5/8, 4-inch, 6-inch, 8-inch, 10-inch, 12-inch. Then there's a flange size. Now, flange sizes go by inch, inch and a quarter, inch and an eighth, inch and 3/8, inch and 5/8. And we'll talk more about flange lines later. And then there's another component called gauge, which is the thickness of the metal that's being used for this. And then there's a component called manufacturers. Different manufacturers all use these same components, which is what the Steel Stud Manufacturers Association, all the steel stud manufacturers all got together and said, look, you could think of it as like a car builders. All the car builders came out and said, well, we're going to build cars. Well, there always has to be a windshield, and there has to be 4 wheels, and there has to be engines, and there has to be headlights. They created a car manufacturers association to make sure that when we say what a car is, that they're using the same terminology that a car is a car. Steel stud manufacturers came up with their association that said whoever's making steel studs has to agree that these are the same, we're going to be using the same terminology and the same building factors to make sure that we're building the same. So Clark Dietrich is a manufacturer, Steeler's a manufacturer, Scafco's a manufacturer, all different manufacturers. They may call their studs differently, similar to cars. Ford calls their cars the Ford Focus, Chevy calls theirs the Malibu. They have different models, but the cars do basically the same thing. They have an engine, headlights, doors, steering wheel, gears, move you from point A to point B. But they may have different bells and whistles that make their car more unique, but it's still a car. So a stud is a stud. However, they have different models of those components. So manufacturers have different nomenclature for their products. Okay? So when we're submitting, these are the products that we're going to be using, and we're going to use them over and over again. In the metal, for metal framing, for structural or load-bearing metal framing, it's usually all of this. I'll put it in red. 2.5 is so small, it doesn't have any structural value because it's too small. And sometimes 3 5/8 cannot be considered part of the structural component. And sometimes 4 inch is not. So 6 inches and above is usually your structural members. So in the Division 5 section, you're usually dealing with 6-inch webs and above. So let's talk about steel stud thickness. Steel stud thickness, let me see if I can insert. I put it under. Yeah, let's see if I can get it in there. Yeah, here you go. So gauges of thickness, this is where things get a little bit confusing for people. Steel stud thickness has these elements to it. So I don't know if you guys can see it on screen.
Yep.
Let me maximize here. Let me make this bigger. Okay, can you see this colors now?
Yes.
Okay. So these are the gauges or mils of thickness. The manufacturers refer to it as a mil, which is millimeters. How many millimeter thick it is. The thicker the millimeter, the stronger the material. Okay? Now, when you deal with gauges, the higher the number, the thinner the material. So if you're looking here, you can see 25 gauges, 18 mils. but 12 gauge is 97 mils. So this is where things can get confusing. One number, the higher it goes, the thicker it is. The other number, the lower the number, the thicker it is. So depending on if you're referring to gauge or if you're referring to mils, that's what there is. Our guys in the field refer to it as gauge. And they'll say, oh, I need a 16 gauge stud. A 16 gauge stud, in this example, 16 gauge is 54 mils. And they usually paint those studs, the bottom part of the studs, they paint it with a green paint so that guys can look at the material and know exactly what it is. 20 gauge is white, and then 25 gauge is no color at all. 25 gauge, for you to get a familiar of how thin 25 gauge is, your soda cans that you drink out of are 25 gauge. So you can bend it with your hand. It's like a tin can. It is super thin. Okay, 20 gauge is just above that, and then it goes up from there. When you're dealing with structural stuff, do you think you want thin material or thick material? If you were dealing with the table legs, do you want your table legs to be thin or thick?
Thick.
You want them to be thick. So, in dealing with structural, on the outside of the building, the lowest that you could possibly go is 33 mil. Which is 20 gauge. So let me...
Say that again?
Is 20 gauge. The lowest structural value of a stud, any structural strength by the SSMA, I don't know if you guys can see my... So if you're looking at my screen, I mean, wow. I don't know if you can see my... You can see my screen here.
Mm-hmm.
Over on the left-hand side, this is per the steel stud manufacturer's manual. On the left-hand side, you'll see the mill thickness. It says designation thickness mill. And this is how it's written. It's in thousandths of an inch. And on the right-hand side, it says reference only for gauge number. 33 mil is 20 gauge structural. 30 mil is 20 gauge, but it's non-structural. It's meant to hold drywall. So if you're in Division 5, the lowest, the thickest, the thinnest material you could use is a 33 mil. Okay? So does that make sense why there's two types of 20 gauge? A 20 gauge that's 33 mil, which is meant for structural, and 30 gauge, which is meant for interior. Okay? So here it says 20 gauge, 30, and 33. Since we're talking about Division 5, the thinnest material you will ever get is 20 gauge. Traditionally, architects and structural engineers will not let you ever get anywhere close to using 20 gauge. They like things to be 16 gauge. Okay? 16 gauge is traditionally your structural building material. When you're dealing with floor or ceiling joists, which means people are going to be walking on top of it, and it's going to be in a horizontal application, they like it to be 12 gauge, which here is red, 97 mil. So basically, the only difference that separates the Division 9 cold form metal steel framing and the Division 5 the steel metal stud framing for Division 5 and the metal stud framing for Division 9 is size and thickness and flange. Okay? So you're dealing with the same building material, just the light gauge material, you're dealing in lighter gauge of framing, you're dealing in different flange sizes, and you're dealing in smaller sizes of studs. When you deal with the exterior stuff, you deal in higher numbers of sizes, you deal in higher number of gauges, and higher number of flanges. Okay? So structural is just at the one end of the spectrum there. So when you're doing your submittals, you're going to submit the exact same types of materials, except for you're just going to use different sizes. So this is the structural stuff. This is the light gauge framing stuff. Light gauge framing sometimes goes to 6-inch. Traditionally, light gauge framing never goes up to 8-inch. Your top track and bottom track are always the same size as your studs. So if a stud calls for a 3-and-5 stud, you need a 3-and-5 top track, 3-and-5 bottom track. What's the difference between top track and bottom track? Bottom track is a consistent piece of metal sill, and the top track has slots in it. They refer to it as slotted track, deflection track, slotted slip track. Different manufacturers call their top track different names.
You said they have to always be the same as the studs, is that what you said?
Yeah, the same size of the stud. So if you have a 6-inch stud, you need to have a 6-inch piece of top track and a 6-inch piece of bottom track.
Okay.
Okay? Now, let's jump back to these. So does that answer the question about these studs here?
Yes.
About cold form metal steel? We pick from our building. So anytime that we are, so how do I put this? So earlier we talked in our training about how you start is you look at the drawings, you jump to the spec sections, you jump to the drawings, and then you go to the building products. Now, here's a little bit of the paradox, or that it's all reverse collated, meaning that the building products that we use, we traditionally use the same building products over and over again on every single project. Once you know your building products and your building materials, you then just double check your specs and double check your drawings to make sure that they are reflecting what we want to build with. So one part you could look at as saying the specs and the drawings are telling us what to build with, and the other is saying we know what we're building with, and we want to just double check to make sure that the architect is using the products that we're specifying. So once you become more knowledgeable about building, which I misspelled this here. Once you get more familiar with your building products and materials, when you look at your specs and you look at your drawings, it will go very quickly because we're always using the same stuff over and over again. So where I'd like for us to get to is to build a submittal package, a standard submittal package for our Division 5, our Division 6, Division 7, and Division 9s. That if we created a standard saying this is the common stuff that we use all the time, and then we just double check the specs and we double check the drawings to make sure they're calling that out and looking for any specialty items that may be called out in the drawings. Okay? So that's where getting familiar with our building products will inform the specs and the drawings. And we'll just do the same thing over and over again. Now, let's talk about, it's worth noting now, and I haven't developed it yet, but JIP shaft wall assemblies. JIP shaft wall assemblies consists of different framing material than other walls. They have, instead of a top track and a bottom track, they have what they refer to as a J track. And instead of regular studs, they have I studs, H studs, or CH studs. Still a stud, but it has a different configuration. And it's meant to hold shaft liner. Okay? And it has some different, it might have some different type of screwing that goes through it. But it has metal, it has similar stuff to his non-load bearing, but it has specialty items, J-track, CH studs, and things like that to comply, and they have different ASTM ratings. Shaft walls are designed to stop, or to, yeah, are usually thicker building material as it's designed to stop fire. Shaft walls go all the way through the building, and it's designed to, they usually has a minimum of a 2-hour fire rating. So the studs need to not melt after 2 hours. The drywall needs not to melt 2 hours. So it's a different building using a lot of the same materials, but in a different way with different thicknesses. Okay? When we get into ceilings, they use, you can use studs and track. Traditionally, they'll refer to it as mains and T's. They want a main and a T. So if you look above your head at the acoustical ceiling tile, you see the panels fit inside of that metal framing.
Agreed.
The metal framing that goes from wall to wall is referred to as the mains. And if you look at, there's certain framing members that go from main to main, they're little or short pieces. Those are referred to as T's. So the long pieces are mains, the short pieces are T's. And then the piece that goes around the perimeter is referred to as molding.
Molding.
Now the word molding will occur on the exterior part of the building as well. You'll hear words like shadow molding and interior molding, crown molding. If you've been in a room that at the head of the wall, you'll hear crown molding. Molding, it goes around the perimeter of a room. You have the ceiling perimeter and you have the floor perimeter. So if you hear wall molding, there's also molding down on the floor. They sometimes refer to as skirts. If you're doing different flooring, they'll say, oh, I need to attach to the wall molding to cover up the gap between where the flooring and the wall meets. Okay. And also part of ceiling stuff is there's compression posts and ceiling wires. Again, as we jump into these building products, different manufacturers call different things, and you're going to find different varieties of all these products. But this gives you a general overview of the things that we always submit on in regards to these spec sections. Okay? Some vary project to project, meaning that sometimes on a project we won't be using anchor bolts, that won't be required, or hold downs, that's sometimes varies. But this just gives you a list to check and questions to ask when you're doing your submittal. Okay. So we've covered kind of the metal framing component. That's a majority of our items. Because we use foundation building material, we use a company called Clark Dietrich. Clark Dietrich, if you wanted to do submittals and generate your own submittals, one way you can do it is go onto the Clark Dietrich website, which right here. Every manufacturer has a website that allows you to pick from a list of their products and submit it. Okay, so if we don't have the information, every manufacturer's, their websites, they want you to use their products, so they provide you with tons of information about their product. So we're on here, you can see that they have different types of clips, different kind of bridges, U-channels, fern channels, resilient channels, web stiffeners, flat strap, angle, backing. This is under the clips and accessories. If you're under exterior framing, here's the studs and track, and then you just type in the web depth, meaning do I want it to be a 2.5, 3-inch, 4-inch, 6-inch, 8-inch, and what's the flanges, what kind of thickness do you want, and if there's a specialty type of coating, and you'll see that in the spec. And whenever you need a stud, you need a piece of track that is the same size as that, and that's what they'll put. And then the top track, in this case, they refer to it as their deflection track. They have different types of deflection track. Here's your slotted deflection track, max track. So everything that you need from the metal manufacturer is on the Clark Dietrich submittals, so that you can do submittals from them if you need to pull the data. Because we do the same things over and over again, once we pull that data, we don't need to pull the data again unless they do an update, and we can submit the same package to every single project because we're using the same product. So once you do one submittal package, you can use it over and over again for each project because it's the same stuff. Okay? So that covers metal framing. Any questions about the metal framing, ceilings, anything like that? Because our next big component we're coming up to is gypsum.
I've got a question about the flange and the,
Yes.
was it the leg depth and whatnot? If those specific sizes are not called out in the specs and you can't find them in the plans, what is the general rule of thumb?
Okay.
Or are those things always called out in the plans and they're just sometimes difficult to find?
No, they usually don't call out the flange. So that's a great question. They usually don't call out the flange width. They usually call out the stud depth. The spec sections, because we have a variety of flange widths, the wider the flange, the stronger the stud. So typically, we use 1 1/4 inch flange. As you see here, it says S125. We use 1 1/4 inch. That's usually the thinnest part of material that we use, that's the smallest flange that we use, is 1 1/4 inch. That's typical. They usually carry that. That's common practice that they carry that. How they determine that if your stud is going to be the right fit. There's a thing referred to as a span chart. So let's take a look. I'll show you where I put some information. So underneath DMS Management Group Company, under submittals, I have created different folders, and we're going to walk through this. But so right now, metal framing, joints and sealants, insulation, gypsum, fasteners, access panels. Under metal framing, there is this structural interior wall heights. If you open that up, this tells you how far you can span. Meaning that a 2.5 inch stud with what's 137? 137 is 1 5/8 inch flange, or sorry, 1 3/8 inch flange. With an 1 3/8 inch flange will allow you to span 17'6" if you're spaced at 12 inches on center. If you're spaced at 16 on center, which means that you're spreading them further apart, so the wall has more weight to carry, you can only go 15 feet. If you're only 2 feet, it's 13 feet is your max that you'll be able to, how high a wall you can use that material. So we don't use a lot of 2.5 inch. So you got to come down here to 3 and 5. 3 and 5. Sorry, let me back up for a second because what I said was incorrect. So our typical stud flange size is 1 inch and 3/8. It's the 137. Oh, sorry. Let me look. Let me go to the next page. Yeah, 137. 137 is I think the lowest that we go, and 1 inch and 5/8, which is the 162 studs. That's common. So if we're trying to save money, we use the 137. If we're using typical off the stock shelf stuff, it's the 162. And this gives you your charts. Okay, so to help determine that, I would submit both. You know, just change, say, here's the product with this flange size, and here's the product, so we have a variety to choose from. And the guys can use that whenever they're building, because sometimes walls extend higher or they need to attach to something. They'll put those items in. That gives them a variety of options to choose from. Okay, so a span chart tells us how far and what flange size and which gauge for us to accomplish how high the wall needs to be built. Okay, which sometimes isn't called out in the drawings. They just said, look, you need to comply with whatever your steel stud manufacturer says about that. Okay, so the two common ones are the 137 and the 162. So I'd submit both those as a common practice.
Okay.
And for steel stud gauges, for exterior, meaning the structural stuff, I would submit, traditionally I always submit 16 gauge. And unless they're telling me, calling out the gauge thickness, I always submit 16 gauge. Unless they note it needs to be 12 gauge, then I'll submit 12 gauge. I traditionally never submit 14 gauge because I'm usually always trying to push it down to 16, or I'm trying to elevate it up to 12 gauge. So I usually use 12, 16, and then on the walls, on the interior side, they usually always use 20 gauge. And I'll use a 20 gauge drywall one. So I'll submit the 30 and the 33 in case I need the heavier. That's your typical, most common used items. Okay. Any more questions about the metal framing? Those are great questions.
Not that I can think of right now.
Okay, great. So you ready to move on to gypsum?
Yeah. Let me grab something to drink real quick.
Okay.
Do you want anything, Vanessa?
Good, thank you. Let's see. Hello. Hey.
I'm in my office.
Okay, so now we're going to jump into gypsum. So on these spec sections, the metal stud framing and the gypsum are majority part of our work. The other spec sections, plywood, thermal insulation, we'll go deeper into those when you're actually built, when we get into this, but the drywall has the widest variety of items because it affects your shaft walls. It's usually applied to majority of our work in regards to ceilings and walls, gypboards there. Okay. So drywall. Gypsum occurs, the thickness, these are the different ways to measure gypsum. Usually the thickness, the width, the length. Our most common size is 5/8 drywall. Sometimes we need 1/2-inch drywall on ceilings or on certain walls that need to maintain a certain plane. meaning they need the wall to fur out or to be built out so that it's a consistent line. And they might use half-inch drywall to use it to maintain a certain line on the wall. Quarter-inch drywall is very rarely used. If it is used, it's usually used to wrap like columns or things because it's so thin. It's very flexible. And so you can use it to bend around soffits. You can use it to bend around radiuses. Quarter-inch drywall allows you to, it's very flexible to get around curves and radius and things like that. That's where you use quarter-inch, but quarter-inch is very rarely used. 3/4-inch drywall is also rarely used. 3/4-inch drywall is used as a value engineering, meaning that sometimes they call out for 2 layers of 5/8 drywall. You can use a 3/4-inch piece of drywall, 3/4-inch piece of drywall to maintain the same type of rating. So 5/8 is your most common one, and it's going to be part of our standard package wherever we're doing stuff. The width, the standard width of drywall is always 4 feet. In specialty cases, they can change that and run a special type of drywall that has a different width to it. Now, lengths. The standard length is 8 feet. The next standard length is 12 feet, and then the one after that is 10 feet. They make a majority, like I said, majority they make is 8 foot, then 12 foot, then 10 foot. Depending on how the building is being built, if we have to use an elevator or a man lift, getting 12-foot board inside of a man lift is extremely difficult. Usually the carriage of the man lift is like 11 foot and a half. So you can't get the 12-foot drywall in. The reason why you would use 12-foot drywall means that there's less cuts because you can cover more area. And that means that it'll save on the taper's time because the taper doesn't have to tape as many joints because you have a larger piece of drywall. So I usually submit all 3 sizes in a submittal. I usually say 5/8, 4, and then I just highlight 8 foot, 10 foot, and 12 foot. Now, let's talk about the menu. Any questions about that? No? Okay. Manufacturers. Here's where the world gets a little confusing. So on this page, I have created a link to every single one of the main manufacturers' websites. When it comes to drywall, there are a wide variety of types of drywall. So when submitting drywall, we kind of have to walk through all these parts and pieces because it's such a wide variety. FBM carries all 4 of these main manufacturers. So one of the type manufacturers is called National Gypsum Company. The other one is USG. The other one is Georgia Pacific, or called GP, and the other is Pabco. These 4 manufacturers, Pabco is located in the San Francisco Bay Area, GP is located in the San Francisco Bay Area, and National has a plant in the San Francisco Bay Area. USG does not have a plant in the San Francisco Bay Area. They have one in Las Vegas, and they ship to the San Francisco Bay Area. Because guys use drywall, have been using drywall for a long time, they will use these words interchangeably, but it doesn't necessarily mean they're calling out the exact product. So to have that kind of be more relatable, what that means is if you're east of the Mississippi, I think you call Coca-Cola, you might call it soda. Right? You call it, hey, I'm going to get a can of soda. You know, a soft drink, you call it soda. And west of the Mississippi, they call it pop. Right? Call it pop. It's soda pop. They call it pop. And in Texas, they call it Coke.
They call it Dr. Pepper, actually.
Or Dr. Pepper. You say, oh, can I get a Dr. Pepper? And then they'll ask you what kind. And you're like, what do you mean what kind? You're like, yeah, what kind of Dr. Pepper? You're like, a Coke. Oh, okay, you want a Coke? It's like, oh, okay. So same is true for drywall. So National, they use their main term for their drywall is called Gold Bond. USG, their main term for theirs is called sheetrock. Hence why everybody heard, oh, I got to grab some sheetrock. That refers to USG's brand of wallboard or gypsum wall panel. GP calls theirs tough rock, or if it's got a fiberglass mesh on it, it's referred to as a DENS product. DENS Shield, DENS Glass, DENS Armor Plus. They named all their stuff DENS. Pabco calls their stuff Pabco, or they'll use the word curb. So if you look at this example, let's go over here as examples. You have regular type of drywall. You have fire-rated drywall. You got water-resistant drywall. You got mold-resistant drywall. You got tile backer drywall. You got abuse-resistant drywall. You got sound drywall. You got shaft liner drywall. You got shaft liner fiberglass drywall. You got plaster board drywall. You got exterior drywall. These are all the different types of drywall. So let's take a look at the mold type. National refers to their type of board as the mold resistant type. They call theirs Mold Bond. USG calls theirs Mold Rock. GP calls theirs Mold Tough. And Pabco calls theirs Mold Curb. So if a guy says, oh, hey, I need to get some Mold Tough out here, he's referring to mold drywall, but we might have spec'd National. In other words, we might have submitted saying we want to use National. So it's actually Mold Bond, but our guys will call it Mold Tough. So when it comes to tile backer board, or sometimes called cement board is another one. USG calls their Durarock, and GP calls theirs DENS Shield. And I haven't looked up yet what Pabco calls there. They may call it tile curb, and National may call it tile bond. So guys may say, hey, I need to get some Durarock out here, but that's like saying I need to get some like imagine you live in Texas. I need a Dr. Pepper out here. Well, what kind? If you have to translate what they're saying, so when they put in the order, they're going to be ordering this type. Now, let's talk about pricing. Pricing, USG is usually the most expensive type of board there is. Then it goes GP, then it goes National, then it goes Pabco. Pabco is not able to manufacture as much board as the industry demands right now. So National is the most economical and readily available type of drywall there is. Our guys usually order National drywall. That's what they will carry, depending on whatever we submit it. So when submitting, we usually submit National products. Okay. You can also submit USG. If USG is usually called out in the specs, USG does a lot of testing on their board. USG is like the Cadillac or the Rolls Royce of drywall. They do all their testing. They do a bunch of stuff. They're leaders in the industry. They're very, very, very high end. Because of that, it's reflected in their price. If you use USG, you're going to be safe with any kind of ULs or testing stuff. USG's got it all covered because they got it. They're the leaders. National usually creates something to reflect what USG's creating, so it's kind of a knockoff brand. Okay. So National is what our guys mostly use out here because it's readily available, because USG has to come out of Las Vegas and they're having a hard time keeping up with the supply, the demand that's out here in California. Okay. So National. Now here's where things get a little more elaborate. Since National, USG, GP, and Pabco are all making different types of wall boards, they also make their own type of joint compound. The joint compound that we use is USG. You can use USG compound on National drywall or GP drywall or Pabco drywall. We always use the same kind of joint compound, same type of accessories on every single project. Okay, there's only two big players when it comes to the joint compound industry. One, it used to be called Hamilton, now it's called Westpac, and the other is USG. Those are the big ones. It's like the Apple and Android markets. The Microsoft phone that came out, that would be like these guys here. The joint compounds that come from any one of these guys, they're all small knockoff stuff. USG is what we submit. And there's a variety of joint compounds. There's taping mud or taping compound, and there's topping compound. What's the difference between taping compound and topping compound? You can think of it in their name.
Is used to it helps adhere with the tape. It's the stuff you put on before you tape, right?
Yeah, so the taping compound has more adhesive in it than the topping compound. Taping compound is used to stick the paper tape on the wall. So you're going to order less. You're going to order less taping compound and more topping compound. Okay? So taping compound is used because it has more glue or adhesive in it. It allows things to stick better. Topping compound is easier to sand. It's got less glue in it, so it finishes the wall better. Okay? And then they have a thing called all-purpose. All-purpose means that it can tape and top. It's in the middle. It's got a little less adhesive than taping compound, but a little more than topping compound. So all-purpose is in the middle. And we'll go deeper into all the stuff when you're doing your submittals, but this just gives you an overview of taping, topping, all-purpose. There is another one that we will use depending on how projects go, and they will refer to it as hot mud. And they usually will refer to hot mud by the number of minutes. Okay, so you have a 90-minute hot mud, you have a 60-minute hot mud, you have a 30-minute hot mud, and I think there's even a 10-minute hot mud. So based upon what I just shared, what do we think hot mud is?
It dries quickly.
That's right. Hot mud has a chemical additive in it that allows it to dry very quickly. So if you want it to dry in 90 minutes, you use 90-minute hot mud. If you want it to dry in 60-minute hot mud, so on and so forth. 10-minute hot mud is full of a bunch of chemicals that react to have it dry very quickly. Our guys, I don't think you ever use 10-minute hot mud, but they will use 60-minute hot mud or 90-minute hot mud. The reason it affects the quality of the finish. whenever you use hot mud, it doesn't finish the same as using topping mud. Topping mud traditionally takes 24 hours to dry. But if you're trying to get a building done quickly, they'll say, oh, can we use some hot mud so that it dries faster so you can do it. The challenge is it doesn't sand and it doesn't finish the look of it. It doesn't remain consistent because it has different chemicals in it, so it will dry it different. It will create different marks inside the compound than anything else.
And that's the 90 and 60 mud you said?
Yeah, all hot mud or 10-minute, 30-minute, 40-minute, whatever minute hot mud there is, that is used as a patching type of mud. Oh, I just need to do a patch. I need to get in and get out and get it done quickly. You would use it as that. So I'll usually submit something like that. And they usually bundle that together. They'll say, oh, here's your hot mud selection. And I submit the whole package. I just click all the boxes, say, oh, we might use 60-minute hot, 90-minute. We might use all these. And I just submit it in the package. It complies with everything. The only difference is the chemical compound that dries it out. Okay, accessories. Accessories are your corner beads, your J trims, reveals. The standard trim is corner bead. We usually use an inside corner bead and an outside corner bead. And when I go through, we'll create a standard package that has these components in it. And we have standard fasteners that we use. For metal framing, we always use a Waferhead Tech number 10s that are 1.5 inches long. And for drywall screws, we always use phosphate Buglehead 1 5/8 or 2.5 inch long screws, depending on if we're going through 2 layers. And we use steel pins for structural framing, and we use concrete pins when we're attaching to concrete. We use both those pin sets for the Division 5 structural framing and Division 9. So when you do your submittal, it's like, oh, you just copy and paste the same thing because we use the same type of power actuated fasteners for both those divisions. And then you get into the world of sealants. Each one of these manufacturers makes fasteners. They make screws, they make adhesives, and they make sealants. So as the companies grew, they make all this stuff. We don't buy all their stuff. We don't buy all their things that they do. We buy screws from a company called Grabber and Hilti. We use Hilti and Grabber in regards to screws and fasteners. Those are our 2 main manufacturers for those. Okay. But just on the drywall section, we kind of covered. If you click on any one of these links, which I will here, if you click on these links, they have a ton of resources for you to learn about their product and how to install their product and what it means. From sound isolation, fiberglass matted panels, there's an app that you can use to determine wood panel products. They do estimating courses. They do lead calculations. Anything you need for lead, they have on here. So I'm going to go under Gypsum Products Home. You can click on every single one of these things. And they'll give you estimating tools. They can even give you their own spec section. Here's a technical guide. Here's video on how to install it. Helps you do your submittals. Here's warranty information, brochures, profiles, other different products that go with it. And so sometimes I will go through and look at just different drywall manufacturers like Pavco here and see what's updated on their website. So I go to the products. And they have now a light core. So when it comes to drywall, see here's flame curb, water curb. That's their water resistant boards, water curb. So when you look in here, one of the things that they're trying to do, because the drywall market is so competitive, one is how do I make my board meet the fire, water, mold, sound, cement board, tile backer board stuff that's out there. And now where everybody's trending to is they're trying to make their boards lighter. Less weight. Less weight means our guys can pick stuff up and it's not going to be as fatiguing, which means if our guys are lifting less weight, they'll be able to produce more because their muscles will not get fatigued over time. So they're trying to look for an advantage anywhere they can. So you're going to start to see all these lightweight products coming out. USG has a lightweight product, GP has a lightweight product, and Padco has a lightweight product. They're trying to find any ways that they can get a competitive advantage in the market. Okay? So feel free to check out their websites. There's, tons of information on how to build stuff, including shaft wall assemblies, and they're nothing but a huge help. Okay? So let's jump back to our spec sections. In regards to finishes, we've covered gypsum board. We're not going to go into really any other spec sections, just knowing that for thermal insulation and fire stopping and sealants, the specs, the Division 7, that goes deeper, and we'll work with that on a case-by-case basis. But you'll see examples of what I'm talking about with thermal insulation. You either have bad insulation or mineral wool. For fire stopping, you have fire safing or fire caulking. For joints and sealants, we have acoustical caulking or smoke and sound seal. I'm going to dive deeper into this with you guys as we develop each one, but these are the basic components of what needs to be submitted for each one of these categories. So you can basically pick your products, then look at your specs, then look at your drawings. Saying, oh, here's my products. I need to go check the specs, make sure what we're submitting complies. We need to check with the drawings to make sure what we're submitting meets the criteria and find any oddball stuff. So knowing your products is step 1, then specs and drawings are step 2 and 3. Okay? Any questions about what we covered?
No.
Allison?
No, the gypsum section is fairly easy. It's just like the more in-depth ones, like insulation and let's see here, what else? Insulation, fire stopping, and then shaft wall assemblies is what kind of still occasionally stump me, but
Yep.
like they're more like in-depth questions where it would take a chunk of time to elaborate on.
Yep. Yep. And now we're adding plaster to this. So getting familiar with the building materials that is needed for plaster, which you need 16-minute paper, 2-ply, you got to understand all the trims, the lath and plaster trims, the lath trims and accessories. And then you have to understand if it's a 1-coat, 2-coat, and then sampling. So each one of these spec sections can be pretty extensive. And we'll do more training at a different point in time to go through that stuff, but this gives you kind of an overview of where we're at and where things will start to develop in regards to being able to do submittals. Chelsea, anything for you?
Nope. Nice job.
All right. Great job, guys. Thanks for being here, being on the call.